In this video, we're going to take a look at this interesting physics problem because it's not so clear that there is an answer for this question. And the situation is that this box is getting pulled at a 30-degree angle above the horizontal with a force of 40 newtons. And in situation B, it's also being pulled at an angle but below the horizontal and also at 40 degrees, at 40 newtons. And we're asked to compare the frictional force between the one on the left and the one on the right. Now we know that kinetic friction, because this is sliding on the surface, is equal to coefficient of kinetic friction times the normal force. Now the normal force here is not simply the weight, because there's also this force that's pulled at an angle. So I want to start with a force diagram. So I have Fg, and Fg is 50 newtons, and this is pulled at an angle of 40 newtons. And I'm going to break this into components. So here I'm going to break this into these two components. Here's my angle theta, which is 30 degrees. So because this is next to the angle, so this is going to be cosine. So this will be 40 cosine 30. And then this side will be 40 sine 30. Okay, and 40 sine 30 is equal to 20. This will be 20 newtons. So since this is not accelerating up or down, I know that this net force vertically should be 0. So vertically, something plus 20, because there's a normal force, the normal force needs to be, the Fn needs to be 30, because 30 newtons plus 20 newtons equals 50 newtons. Okay, so then the friction here, Fk is mu times Fn. So I know it's going to be, the normal force is 30, so it's going to be 30 mu. Okay, so I'm going to just circle that there. So that is the friction. I don't know what mu is, but it's the same surface, so it's going to be 30 mu for A, situation A. Now let's take a look at situation B here. Now this is getting pulled downward, okay? And there's also gravitational force. Gravitational force is still 50 newtons. And I'm going to break this into horizontal and vertical components. Here's the theta. Since this is next to the angle, this will be cosine. So this will be cosine 40 cosine 30. I'm not really worried about that right now. I'm really looking at the vertical component here. And this will be 40 sine 30 degrees, which is 20 newtons. Okay. So, so vertically is not accelerating, so I know that the net force vertically needs to equal 0. So 50 plus, this is 50, sorry, that's 20, and that's 50. This going up needs to cancel that, so this is going to be, the normal force is going to be 70 newtons. Okay, so this is 70 newtons, and then now for the friction, Fk, we know Fk is equal to mu times Fn. Okay, so what is Fn? Fn is 70, so this is going to be 70 times mu. Okay, so right now, at least initially, it looks like that the friction in B is greater. So that's what it looks like. However, in this case, these two boxes are moving at constant speed. They're moving at constant speed. So if they're moving at constant speed, that means that the acceleration is 0, okay? Acceleration is 0. And it also means that, so if acceleration is 0, that means that the net force is also 0. If the net force is 0, that means the friction force is equal to, the sum of the forces horizontally needs to equal 0. Now, horizontally, let me change my color here real quick. Horizontally, 40 cosine 30 is 35 newtons. So in order for this to be moving at constant speed, what would the friction force have to be? It would have to be 35 newtons, okay? How about over here, 40 cosine 30? This is also 35 newtons, okay? So in order for this to be going at constant speed, what would the friction have to be? It also would have to be 35 newtons because the net force is 0 if it's going at constant speed, right? So if you analyze this using the vertical forces and to use the normal force to calculate the kinetic friction, you would conclude that B has a greater friction than A. However, if you look at it horizontally, considering the constant speed, if you're looking at the constant speed part of this, then you would conclude that they would have the same friction because they're not accelerating. The net force needs to equal 0. You need to have a friction of 35 to balance out the horizontal component of this force that's being pulled at an angle, right? So my question to you is, how can you rewrite this question so that you can actually just get one answer? Let me know in the comments. Thanks.